Welcome out there. It's Mathline time, and you have tuned into the right place. I'm Ernie Roberts. I'm your host for this afternoon session of Mathline. We're glad you tuned in with us here. And what we really want to hear from you is let's get some calls in, all right? That 844-686-2378. Free. Does not cost you a dime to call us, all right? And it's toll free. We want to hear from you. Give us a call. Let's get some math problems rolling on the air. We would love to talk some math here, work some problems together, help some folks out. That would be young. Hey, some of our more mature folks can give calls also, all right? But anyway, we're glad you tuned in. We've got a lot of good things in store for you, but you know what? We'd like for you to be a part of it too. So get those questions, get those problems ready, and let's see if we can't get those phones ringing, get our operators working hard today. And to get us started, let's take a look at our problem of the day. You know, it's getting Halloween time, and Sherb has been walking on a track preparing for trick or treat. All right. One trip around the track is 440 yards. This is one of those, you can see around where your football field is, going around the circle, around the path, and all that good stuff. How many trips around the track will make a total of 4 miles? Now, what I'm seeing here is we're talking yards, we're talking miles, so we're going to have to figure out some way to get out of this one, all right? See what's going to happen. So let's take a look and see, first of all, where are we going on this thing, all right? So let's take a look at the problem. And again, Sherb, love it. Good. It's good to be out there walking. It's healthy. It's good for you. It's good therapy, all those good things. And preparing for trick or treat, that means she's going to be walking about 4 miles of trick or treat. She's got one heck of a neighborhood to work out of, that seems like. So, but anyway, 440 yards is one trip around the track, but she's shooting for 4 miles. It's going to be a long night, it sounds like, or maybe she's just got a good place to go. I don't know. But anyway, how many trips around the track are going to make that 4 miles happen? So what we got to think about here is, first of all, what is a mile worth in terms of yards? Okay, that is my first thought. Question mark. How many yards? Some of you are going like, probably yelling at the screen. I know the answer to that. I know the answer to that. And I think I do too, but I want us to think about it just a little bit. So let's just see what happens when we start going around this track, all right? If you take 2 laps, wow, let's see. First of all, let's do 1 lap. We also know 1 lap equals 440 yards. There's a reason it does that. They built them in a certain way. Hint, hint. 2 laps. Let's double it. 880 yards. We're going to play with this a little bit here, all right, folks? That's what I like to do from time to time. So let's do a 3rd lap. And where are we going to be? My goodness, we're going to be at 3 laps. You know where we're going here? I don't know. How many? Add another 440 to that. Do we need a little calculator time on that? How about 1320? And that's yards still, folks. And let's go for a 4th lap. And we're at, 1,760. And that's the number I want us to kind of think about, because that's how many yards are in 1 mile. So you see, when they develop these tracks for running and walking and all those good things, basically, if you go around 4 times, you got a mile, all right? Now, Sherb, you're looking for 4 miles here. So let's go back here one more notch here. This equals, my friends, 1 mile. Yay. You thought, Ernie, what are you going to do? Add this forever? No. There's 1 mile. So if it takes this amount right here, 4 laps, all of these are all equivalents, okay? They're all the same distance you're covering. It's just in a different way to talk about it. We got laps, we got yards, and we got miles. So we're going to go for 4 miles. And the question is, how many trips, or how many laps, I like to call them that, around the track will she go? How about it? Looks like 4 times 4, which will give you 16. That wasn't so bad, was it? All right. So once again, 4 laps per mile, and you want to go for 4 miles, it's going to give you 4 times 4, which gives you 16. Can we drop that lower third out just 1 second? Let me go for a little dimensional analysis here. You're like, what? Yeah, what is that? I want to go that was 4 laps per mile. Yesterday when Gary Petco was on here, we did the same thing with these things. And what we're going to do is we're going to go for, it looks like, 4 miles. I want everybody to see how you know these are going to work. All right, so laps per mile times 4 miles. The miles are going to take a cancel in units here. Now notice, this is like being over 1 mile here. So we've got 4 times 4. Keep the laps. We didn't have anything to cancel out the laps with. That's going to give us our 16 laps. Another way to look at that, those you get into the chemistry, physics, when you're talking about, goodness, grams and ounces and pounds and feet per square, all these good things, miles per gallon, that kind of stuff. It all has to do with this, what we call a little dimensional analysis. And hey, we did some of this right there. So Sharp, enjoyed walking on that track. Happy trick or treat to you. Got 2 more days, you know, and then it all comes loose. Speaking of which, I understand I have a caller waiting for me. So welcome to Mathline this afternoon. Who am I talking with?
So that's Gabriel. That is from that.
And you are who?
Gabriel.
Gabriel, there we go. I get a better connection. Where are you calling from, Gabriel? What city or what county?
I think Claryville.
Okay, well, we're glad to have you today here, all right? And what kind of math problem you got for me?
It's a decimal division problem.
Okay, decimal division. We love those, right? So what we got? What can you give it to me here?
It's 1.32.
All right.
Divided by 0.33.
Okay, 0.33. I want to make sure I got that decimal place in the right place. Does that look right? Funny decimal,
Yep.
isn't it? There we go. We got the 0 in front of the decimal, right?
Mm-hmm.
And what we're thinking here is, all right, what we're going to look at here, I'm just going to think about how many times, we're going to just play with this a little bit, all right? Because what I'm noticing is, and sometimes I like to see them written like this. On this one, we can go with or without it, but I'm going to put it in this manner so we know that we're dividing this amount into this one right over here. Does that make you feel okay? Can we do that?
Yeah.
Good. All right. So what we got to do here is think about the numbers we got here. We actually, if we were to forget about the decimals, we would be doing what? We look like we'd be dividing what? 33 into what? 132. Does that make sense to you? Sort of, I mean, that's what we're doing. What we got to figure out is what do we do with those crazy decimals? And what we're going to do is we're going to see if we can move them out of the picture a little bit. At least move them to where we don't have to mess with them. We can start thinking about doing whole numbers, all right? Does that make sense to you, what I'm saying?
Yeah.
All right. So what I'm going to do is I'm going to shift this one 2 places. And basically what that means is, Gabriel, I have just multiplied by 100, so to speak. Now, you don't really see that, but shifting decimal 2 places means we multiply by 100 when we shift to the right. Okay? You follow me? So, but if I do it to this little guy out here, guess what? I've got to do it inside here. It's kind of like every time we do adjust somewhere, we got to adjust somewhere else to make the problem still what it is. Okay? So we're going to multiply, we're going to do the same thing. We're going to move them 2 places, just like multiplying by 100. Okay? Now, look what we have. We now have this problem. 33 dividing it into 132. I like the look. Didn't that seem a little bit easier? And you know what? There is a decimal in the problem. It's right after the 2. And we'll probably want to use that here in just a second. We'll see what's going to happen, all right? We may or may not need it, but we're going to try, all right? So let's see. If it comes out even, life is good. You know that, right? We always like it when things come out even. Now, I'm going to play a little guesstimation here. I'm seeing a 3, and I'm seeing certainly it won't go into 1, but it'll go into 13. I'm going to go with the fact that if I had a 12 there, I know it would go in there. 3 would go in there, what, 4 times? So off to the side, I'm going to play with that a little bit. I'm going to say, well, what's 33 times 4? And I'm happy with those numbers that you gave me. Sometimes we get some that are kind of crazy. This one looks like we're going to say 3 times 4. I bet you can tell me what 3 times 4 is, how much we're going to get. With 3 times 4? You got that one?
Yeah, let me think.
That's all right. That's going to be 12. I'll help you out a little bit there, okay?
Okay.
Sometimes when you're on TV, it's all of a sudden, I don't know. And you really do. I'm sure you did. But you know what? We're going to put a little 1 up there because we got to do 3 times 4 once again. Now, this time I know you know what it is. What are we going to get when we say 3 times 4?
12.
And we're going to add that 1 to it, and we're going to get 132. Well, guess what? Gabriel, that's the same thing we got right there. So that's exactly what we want. So I'm going to put a 4 up here. By the way, notice I'm talking about 33 going into what? 132. So I need to put my 4 right up there. Now we estimated to get started, but I have to put the 4 because I'm dealing with the 33, not just the 3 and the 13. So I've got to put that 4 directly above that 2. And we're going to say 4 times 33, which we already figured out, right? It's how much? 132, correct? And look what happens when you subtract. What do you got? Absolutely nothing left, right? Now the question mark, I said, remember we moved that decimal, but that decimal is going to go straight up. So it's just 4. 4 with a decimal after it, just same thing as saying 4. Does that help you see that a little bit?
Yep.
Does that help you? And basically what triggered the whole reaction was, let's get this thing under control. If we can move the decimal here, then we've got to move it there. All right? But it's all about out here. Now, if you'd had 33 without a decimal there, we wouldn't be worrying about it, would we? Wouldn't be moving anything around. It would just make the problem worse, wouldn't it? To add zeros and things like that. So it's if you see a decimal out in the outer part there, or what you're dividing by in your divisor, then that's where you do the shifting. That's where you move. Does that help you out?
Yep.
All right. Thanks for calling in today. All right. And my friends, it's that easy. Gabriel has led the way. Let's get some more folks on that. All right. That number, 844-686-2378. We always love it when we get to hear live callers and get to work together live on this on the air. And again, lots of different ways that we can look at problems like that. But to me, sometimes it's the decimal that makes us a little bit nervous. We can move that decimal out of the picture, or at least get it under control. Hey, it's pretty easy to solve the rest of it, because it's just like doing long division, as she was saying, division of decimals, and a little bit of long division going in there. At least it didn't take long to do it. Hey, how about some geometry while we're waiting for a call, all right? 844-686-2378. That's the number. We want to hear from everybody and anyone out there that has got some problems today. Math problems, that is, of course. They say we all have problems, but we want to hear about the math problems, all right? So give us those calls, and we would love, love, love to talk to you here. So hearing the phone ringing now. Hope that's a good problem waiting for us. Let's take a look at this little problem. Speaking of which, a lot of people go like, whoa, lots of lines going there, Ernie. Why don't you just leave one big triangle and let it go? Well, instead, I've created 2 small ones here and 2 small ones here. And oh my goodness, we got a lot. Then we got one here. This one, by the way, is not a triangle, but my goodness, there's a lot of things going on. But what do these boxes mean? It means we got some 90-degree situations going here. So let's look at that. If we put a 90 here and a 90 here, the basic idea is let's find, goodness, what do we got here? Let's find x. Now let's find y. How do we go about doing that? What do you want to do? Well, it looks to me like, and people say, well, how'd you see that? I'm looking for this triangle that has 62 and 90 in it. Now remember, this isn't a triangle here. This is a quadrilateral of sorts. That's not what we're looking for. We want to look at the whole big triangle here that has x in it. Sometimes you just got to stare at it a little bit. Sometimes it'll jump right out at you. But this is what we're worried about. The x, the 62, and the 90. Now, you say, Ernie, why did you worry about it? What about that 90 down there? It's not a side or an angle in the triangle that we're focusing on. It's a different one. That's when we start looking vertically. But this is really more the horizontal flare here. So we've got 90, we've got 62, and we've got x. Wondering, what is x? How many degrees are in x? How do we know? Well, we know there's 180 in a triangle. And some of you probably were already thinking, well, you had a 90-degree angle there. That means you have 90 degrees left for these 2 angles. Now, if you weren't sure of that, you could just say that, oh, how about it? X plus, what is that, 62? Think big, my friends. Plus a 90, and we know that's got to add up to 180. So what we're doing is kind of looking for the missing piece of the puzzle. And what we need to do is just add those 2 together. All right, we can just do that very easily. And we're going to get, looks like x plus 152 equaling to 180. So far, so good. Everybody says, oh, I got that. So what do we got to do to figure out what's going on in here? We need to subtract 152 from 180. So basically, what are we doing? We're adding 2 angles together and subtracting the sum, subtracting the result from 180. And that's where we go. And that's the logical thing you do. When you guys are out there taking ACT or a PSAT or SAT test, and you see a problem like this, you probably don't set up an equation. You think, oh yeah, got to get 180 degrees, bang, 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 me and my calculator, me and my brain, me and everything. We can do it. We got it, all right? We can do it. We got it taken care of. Now, what's going to happen here, we're going to move that 155 or 152. Where did I get 155? We don't know. I don't either. But we're going to subtract it off, and I'm seeing x equals to a 28 there, a little subtraction. So that's degrees. So I'm going to go with it, 28 degrees, because that works this right triangle very nicely. You say, well, Ernie, how are we going to get to y? We're going to look at where it's hanging out. It's up here, the vertical piece right there at the top. And so we're going to be looking at this left, basically this left tall triangle on the left side of my paper here. That's why I call it the left triangle, okay? And you say, well, we know more now than what we had a minute ago. We found out what x was, which will lead us to get where we're going with y. I'm seeing a y. I'm also seeing, oh, there's that 90, because we have a right angle here. That's why it's nice to know that is a right angle, because it makes things work a lot sweeter. And then I've got this 28 and what is it, 25 looks like. That's what we've already discovered. We've got 28 from the earlier problem. Now we're going to use it over here. And I'm seeing add them together. That's what we did a minute ago, right? Add these, well, we need a big angle, don't we? Oh, big 3 ticks there. We need to know what those are. So put them together, we get 53. All right, and it gets us 180. So figuring it out from here, we just need to move some things around. Add them, just like I said, we'll add them all. In fact, all 3 of these angles here is 90 and 25 and 28, but we've already done that part. So let's go ahead and just add the 2 angles. We got y plus 143. That equals to 180. Let's lose the 143. And I'm almost about to lose the page at the bottom. And it looks like what we're going to end up with there, what do you got? 37 sound good? I think it does. It looks like it's going to give us the y equaling to 37 degrees. And so we got 37 degrees up here. And I always have people ask me, well, Ernie, what would happen if you went there? Well, it looks like this little angle next to y is going to be worth how much? Woo! Can we go a little further on that? Let's talk about it. All right, let's see what we've got going on here. By the way, there's another 90 right there. All of a sudden, angles are popping out everywhere. It's crazy, isn't it? And I'm going to tell you something. As we know this is 28 and 90, we can start working on the inside here also. It's crazy. All I ask for is y and x. You say, Ernie, don't push us too far here. But you know, it's going to work out, because these 2 angles should add up to what? 62, which should give us, oh my goodness, these all have to add up to 180. These have to add up to 180. These we know add up to 180 because we figured that out from the beginning. And whew, just take a deep breath, can't we? So let's put a 28 up there. I think that's what we said it would be, right? Because we got 62, we got that. So there's a 28 going right in there. And someone said, wait a minute, Ernie, that angle is 28 and 37. That's 65, isn't it? Well, 65 and 25, look at that. Adds up to 180. So great little figure here. And that's the beauty of the triangles. And so we say, well, what's going to happen there? Well, let you all figure that one out. Do we need to? Oh, how about it? I think we'd have, what, 62 here? Maybe 118? 118? Then you can work all around these angles because they make linear pairs, straight angles, adding up to 180. Some are vertical. They equal each other. Their measures do. Oh, my goodness. That's why this problem's fun. So anyway, understand, I think we have a caller waiting on the line, and I'm sorry I got excited there, but I want y'all to get excited about math too, all right? So give us a call, 844-686-2378 on this Tuesday afternoon, and I understand I have a caller waiting for me. Welcome to Mathline this afternoon. Who am I talking with?
You are talking with Peyton.
Peyton, you're back. We've missed you for a couple of weeks. Been away. How are you doing today, sir?
Doing well. How about you?
I can't complain. Can't complain. We got a good show going today. We had a caller already. Your second caller, you. And I mean, what can I say? It's going to be a good Tuesday. And hopefully get one more here before the end of the show. So, folks, once again, well, I said to Peyton there, 844-686-2378. Now, Peyton, what kind of problem you got for me today?
Solve and graph on a number line.
Ooh, this sounds like an...
Inequality.
I bet it was going to be an inequality. I was going to say it sounds like an inequality. Okay, hang on just a second. We're going to solve and graph. All right, and folks, remember, we're going to be using a number line. Those of you who were watching yesterday, we had one of these kind of problems with Gary Petco also. So must be the time of the year the inequalities are running rampant around the schools and such there. It kind of makes a scary thought, doesn't it? So Peyton, what's your inequality? Tell me what we've got to work with here.
3x minus 14 greater than 5x plus 18.
Ooh, this one's a little more advanced. So let me read it back to you so make sure we got everything right. 3x minus 14, ching, right? Greater than 5x plus 18. Everything's in place, right? Looks like what you've got on your page?
Yes.
Great. Okay. So what we're going to do, my friends, is if there was an equals there, we'd all say jump, 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 go, go, go. And some of you are already saying, hey, I can jump, 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 go, go, go with a greater than or even a less than. But what this is telling me is we're going to basically, things are going to behave fairly similar, Peyton, to what we do with equalities or an equation, all right? So first thing first, I'm going to ask you, can I go ahead and get rid of the 5x? Can you let me do that?
Yeah.
You're all for it, aren't you? Okay, yeah, you're saying I called in for help. You tell me what you're going to do, right? So we'll minus the 5x on both sides because that's what we do. That's what we do in algebra. If we do it to the right, we've got to do it to the left side. Even with greater than, we call this, it's going to be a subtraction moment, so it's going to be subtraction property of inequality to all our viewers out there. And then things look a little bit better. Say goodbye to the 5x's there. I said goodbye, big X through there because it's gone. But over here we have an interesting feature happening. You just picked up a negative 2x. Now, Peyton, that wasn't nice of you to give me that one. You know that, but we'll work with it, all right? We're going to take care of it. Now, what's going to happen from here? We're going to get that x all by its lonesome. That's the idea. So let's add 14 to both sides. And my goodness, I've got negative 2x. I've got a greater than, and we've got, how much is that? 18 plus 14. Let's be careful here, friends. You got to carry a little bit. We can do it mentally. It's 32. It'll be 32. And that's where things are going to be at this point. Peyton, you with me so far? Pretty straightforward, isn't it? Because say we say goodbye to those 14s also. Now,
goodbye to the 14s.
Yeah, here's your tricky. Yeah, you got the idea. Say goodbye to those things. Here's the tricky moment. We're going to divide by the negative 2 because that's what we have to do. We got to get rid of the negative 2. And it's hooked in by multiplication, so we got to divide. But what just happened is we're going to lose the negative over here, making this quantity, I don't know what x is going to be yet, but it's making the quantity go positive. And now this side's going negative, so guess what? We are going to have a shift. Now, we're not, and when I say this, when the signs change, the inequality has to shift, okay? And the signs have changed on both sides, so we've got to shift the inequality from greater than to less than, all right? Still, we don't know what x is, quote, equal to. It's going to equal to a lot of things. In fact, what it is now is saying we're going to be less than negative 16. So if we were to take a number line, I'm going to create a makeshift number line here, and I'm just going to say, hey, here's negative 16. And I don't want to include negative 16. I want it to be an open circle, all right? And then we're going to shade away right here. And why did I shade to the left? Because that's where numbers that are smaller than negative 16 are going to lie. So those are like negative 17, negative 18, and all those fractions and decimals that lie anywhere in between those points, as long as we don't get to negative 16 and above, all right? Because if we go above that, we're in trouble. If we say negative 16, let's go back and check just a second here. If I were to put in negative 16 minus 14 and say greater than 5x plus 18, I'm going to put my negative 18 right back in there. All right, we're going to get, we got a little bit into a box. Sorry about that, folks. What we have here is a negative 80 plus 18, and here we got negative 48 minus 14, and we're trying to get greater than. And what's going on here is if we put a negative 62 and a negative 62, it doesn't work. So that's why we can't include it, Peyton, all right? We cannot include negative 16. It would give us an equal, all right? Now, If we were going to do that, we would have had to have an equals underneath there, and then we would fill in the negative 16. Again, we would check with one of those numbers. I understand we're about run out of time, so let it go at that. Check one of those numbers to the left, and you'll find it doesn't matter where it is. It's going to make that work. And I would use a simple number like an integer, like negative 17 maybe, to make it work. Is that clear for you? Is that good?
Uh-huh.
All right. Hey, thank you for calling. It's good to have you back on the air with us there. And folks, we're about out of time today. Went pretty quick. It always does. Always does. We're having a good time here. But I want you to get your math problems ready. We're going to be alive again tomorrow, but we're going to have Halloween special on Thursday. Not a call-in day, but a Halloween special for you to watch as Friday specialized segments. So we got one more live day this week. You don't want to miss out on it. Put that number 844-686-2378 in your speed dial, and I will be looking for you once again next time.